All right, let's dive into something that seems super simple on the surface, but is actually an incredible piece of engineering under the hood. A ticket booking website. We're going to tear this thing down, and we'll start with the feeling I know we've all had.
You've been there, right? Staring at that loading screen, hitting refresh like a maniac, only to see those two dreaded words, sold out. Now, you might just think, the website crashed again. But the real story, the engineering story, it's way, way more fascinating.
See, what you're really up against isn't just some slow website. It's a data challenge on a truly epic scale. I mean, just try to picture it. 10 million people all trying to grab seats in a 70,000-seat stadium at the exact same time. This isn't just a web problem. It's what engineers call a high-contention, massive throughput problem. In plain English, a whole lot of people fighting for very few things all at once.
So, to solve this, engineers have to deal with this fundamental conflict, this tension that pulls the entire system in two totally opposite directions. It's this constant, delicate balancing act between two critical and honestly competing demands.
Okay, so on one hand, for the millions of people who are just browsing, just looking around, the site needs to be incredibly fast and always, always available. But on the other hand, for the small fraction of people who are actually buying a ticket, the system needs to be perfectly consistent, totally accurate, and almost slow. It has to make sure that one single ticket is never ever sold to two different people. It's got to be lightning fast and meticulously careful, all at the same time.
So, how do we even begin to build this? Well, before we can tackle that 10 million user stampede, we have to lay the foundation. Let's start with the absolute basics, the simple stuff that makes any ticketing site work. First things first, we need to define our core building blocks. Engineers call these entities, but you can just think of them as the main characters in our story. We've got the event itself, the venue where it's happening, the performer, you, the user, the individual ticket, and finally, the booking, which is the transaction that ties it all together.
Now, with these ingredients, building the basic viewing and searching features is pretty straightforward. Services that let you look up event details or search for your favorite artist. This part, it's relatively simple. But, and this is a big but, this is where the easy road ends. Because now, we slam headfirst into the central problem of pretty much any inventory system out there. The race condition. What happens when two different people click buy on the very last ticket at the exact same millisecond? Who actually gets it?
In a really basic, kinda naive system, it's literally just a race. Both user A and user B see the ticket is available. User A starts carefully typing in their credit card number, but user B, they're a faster typer, or maybe they have their info auto-filled. They finish their purchase first. So a few seconds later, when user A finally hits confirm, they get that soul-crushing message. Sorry, this ticket is no longer available.
And this right here, this is why it's such a huge deal. It's not just some technical glitch, it is a fundamentally terrible user experience. You've just spent 5 minutes of your time, you've gotten your hopes up, only to have it all snatched away at the very last second. We absolutely have to do better.
So the crucial insight, the big aha moment is this. We can't let people just race to the checkout. The solution is to temporarily reserve or lock a ticket for a user while they're putting in their details. Kind of like putting an item on hold at a real store.
Now, the most obvious way to do this might be to just put a lock on that tickets row in our main database. But let me tell you, this is a really, really bad idea. Database locks are heavy. They're meant for milliseconds, not the 5 or 10 minutes someone might take to find their wallet. It puts a ton of strain on the database, and even worse, if a user just gets frustrated and closes their browser, that ticket could be locked forever.
The much more elegant, much smarter solution is something called a distributed lock with a TTL, which stands for time to live. So instead of locking our big, slow main database, we use a super fast in-memory system like Redis. When you select a ticket, we create a tiny lock on that ticket's ID in Redis, and we attach a little 10-minute countdown timer to it.
This new approach creates a much, much better user experience. You select a ticket, and boom, a 10-minute lock is instantly created just for you. If you finish paying within that window, great. The system confirms the sale in the main database and deletes the lock. But if you get distracted or change your mind, that little TTL timer just quietly runs out, and Redis automatically puts the ticket back up for sale. It's beautiful, no fuss, no permanent locks, and way less strain on our database.
Okay, so we've solved the double booking problem. That's huge. But what about that 10 million user stampede we talked about at the beginning? How does the system possibly survive the absolute chaos of a global on sale for a superstar artist?
Well, the key insight here is all about the traffic pattern itself. For every one person who is actually trying to buy a ticket, what we call a write operation, you might have 100 or even 1,000 people who are just viewing the event page, hitting refresh over and over and over. This is what we call a read-heavy workload, and knowing that is everything.
So, since most users are just reading data that almost never changes, like the event name, the date, the venue info, we don't need to bother our main database for every single page view. No way. Instead, we use what's called an aggressive caching strategy. We essentially make copies of those pages and store them in a really fast system like Redis. This means we can serve almost all of that page view traffic directly from the cache. It's like a giant shield, protecting our database from that constant storm of refresh clicks.
Caching solves our read problem. But, you see where this is going, it creates a new one. We've just shielded our database from millions of page views. But what happens the second the sale actually starts, and all those millions of people smash the buy button at the exact same time? The cache can't help us with that. Our booking service would just be completely overwhelmed instantly.
And the solution is one you've probably spent some time in, the virtual waiting room. It's basically a digital bouncer for the website. Instead of letting all 10 million people rush the door at once, we put them in an orderly line and then let them into the actual booking site in small, manageable batches that our system can actually handle without falling over.
So here's how it works for you, the user. You join the queue ahead of time, and when the sale starts, everyone is assigned a random spot in line. Then, the system just lets a few thousand people through at a time, giving you those real-time updates so you know where you stand. It takes total chaos and transforms it into a controlled, fair, and, most importantly, a crash-proof process.
So, after all that, what have we actually built? We've gone from a simple web page to a really robust, scalable system that can handle some serious pressure. Let's just quickly recap the engineering playbook we put together.
So, we face a few core problems, right? To stop that double booking race condition, we used a distributed lock with a TTL in Redis. For the insane read traffic from millions of people hitting refresh, we brought in aggressive caching. To handle that sudden purchase rush, we implemented a virtual waiting room. And while we didn't go deep on it today, to make keyword searches super fast, you'd use a dedicated tool like Elasticsearch.
And what's so critical to understand is that these aren't just abstract, technical tricks. These patterns, being able to recognize a specific kind of problem and knowing the right tool to solve it. This is what separates junior engineers from senior ones. It's about solving a real business problem, whether that's user frustration or a system that keeps crashing. And that brings us to our final thought. This whole problem of managing a limited, high-demand inventory isn't unique to concert tickets at all. Think about it. Booking the last window seat on a flight, trying to grab a limited edition pair of sneakers, or even reserving a table at a super popular restaurant. So my question for you is, where else do you see this hidden ticket problem in your daily life? Thanks for joining me.